So now we are going to discuss the control transfer and loop instructions of 8085 microprocessor. The control transfer instructions can be divided into two categories, the unconditional transfer and conditional transfer. It is similar to the branch operations or control transfer operations that we have already studied in 8085 microprocessor, but the only difference is that they are mainly based on the status of the flags. And since in 8086 we have larger number of flags, so the conditions or the control transfer instructions based on the flag values, flag status, we have large instructions in 8086 microprocessor. So let's discuss the unconditional, then we'll discuss the conditional transfer, then we'll come to the loop instructions. So coming starting from the unconditional transfer, we have jump, call and return, similar to 8085 that we have studied. Jump to the address in which we want to jump to the next instruction to execute the next instruction. Call is a kind of subroutine address, a starting address of the subroutine. If we want to go to a subprogram, subroutine within the main program, then we can use call. And to get back to the original main program, we need to use the return. It is basically return procedure from subroutine. So jump address, that means if this instruction comes, then unconditionally the next instruction to be fetched from the address which is given in the jump command. Call, if call comes, then unconditionally you need to fetch the instructions available in the locations given by the address just after the call, and return, get back to the original main program. Some conditional transfers, conditional transfer instructions can be classified in basically the jump instructions. So we have jump on jump if above, jump if above or equal, JA, that is jump if above, JAE, that means jump if above or equal, JB, that means jump if below, and JBE, that means jump if below or equal. JC stands for jump if carry. JCXZ, that means jump if CX, the content in the register CX is equals to 0. JE, it only checks the equal, jump if equal. JG, that means jump if greater. JGE, that means jump if greater or equal. JL, jump if less. JLE, jump if less or equal. We have so many conditional transfers, but let me discuss these instructions first, because we are now on this particular page. Then we'll go to the next page and we'll discuss the next instructions. So JA, that means jump if above, to address. Which address? The address is given by the ADDR just after the JA command. So jump if above, that means the next instruction to be fetched, but that is conditional. So it checks whether the carry flag and zero flag are 0. If they both are true, they both having 0 values, then only the next instruction to be fetched from this address. Otherwise, it will execute the next line. JAE, that means jump if above or equal, that means it should not check the equality, that means Z flag it does not check, it checks only the carry flag. So if it is above, that means carry flag has to be 0, carry flag 0 is only the thing that is checked. So JAE ADDR, if the condition is true, then it goes to ADDR, otherwise it will go to the next instruction. JB, that means jump if below. Now if it is above, then we are checking the carry flag, that is 1. So if it is below, then we'll check when the carry flag is 1. So when the carry flag is 1, that means the jump If below condition is true, that means now it will go to the address location. It will fetch the next instruction from the address given by the command. Jump if below or equal, that means if carry flag is 1 and 0 flag is also 1. So when 0 flag is 1, that means it is equal, and below, that means it is checking the carry flag. It will go to the address. Similarly, JC, jump if carry. If carry flag is 1, it checks only one condition. And you can see that this condition and this condition is same. JC and JB, they both are same. JCXZ, that means jump if contents in the CX register is 0. So CX is 0, Z is for 0, CX is the content in CX, and the J is the jump. So jump if the CX is 0. If we assumed a counter in CX register, a 16-bit counter, then if the content of the CX is 0, then only it can jump to this by using the JCXZ command. JE, jump if equal. Equality is checked by 0 flag. So when the both contents are equal, then 0 flag has to be 1. So 0 flag is 1. That means it is jump if equal. Jump if greater than, that means 0 flag is 0. Obviously, 0 flag is 0. It is greater. And the sign flag equals to the overflow flag. Overflow flag and sign flag, they both has to be same. If sign flag is 1, that means number is negative, and sign flag is 0, that means number is positive. So if number is negative, the sign flag is 1, the number is negative, it should check the overflow flag also. JGE, that means jump if greater or equal. So it will check only when this condition is true. When SF equals to overflow and sign flag, they both are same, then this jump if greater or equal condition true. JL, that means jump if less, that means if SF is not equal to OF. SF is not equal to OF, that means it is simply jump if less. And jump if less or equal, that means Z is equals to 1, 0 flag has to be 1, and this sign flag is not equal to the overflow flag. So these are a few conditional transfers on this particular page. Now coming to the next page, we have jump if not above, jump if not above or equal, jump if not above J and A, jump if not above and equal J and E, J and B, jump if not below, jump if not below or equal J and B E, J and C, jump if not carry, J and E, jump if not equal, J and G, jump if not greater than, J and GE, jump if not greater than or equal, JL, that means jump if not less. So on this page we have these commands, so we'll discuss these commands first, then we'll go to the next page. JNA, that means jump if not above. Not above, that means CF has to be 1 and 0 flag is equals to 1. So in any of these conditions, the JNA command executes. That means if JNA comes and the CF equals to 1 or 0 flag is equals to 1, that means the it will move to the next to the address in which is provided by the instruction. JNAE, that means it only checks the carry flag. That means if above carry flag is 1, it does not check, it checks the equal, that means it has to be 0. So 0, either ZF equals to 0 or it is sufficient if we are checking, because if this does not happen, then obviously this will happen if CF equals to 1. JNB, that means jump if not below. If CF equals to 0, then it go to the address given by the command. And JNBE, if CF and ZF, they both are 0, then the JNBE command executes. That means it will fetch the instructions from the address given by the command. JNC, that means obviously jump if not carry, we have already studied. CF equals to 0, so it will fetch the next instruction from the address provided. JNE, that means if ZF equals to 0, it will check, it will go to the address provided by the instruction. If J and G, we talk about the J and G, that means if jump if not greater, that means ZF equals to 1 and sign flag is not equals to overflow flag. So if these two conditions are true, any of these two conditions are true, then this condition will occur, and the next instruction to be fetched by the address given by this J and G address after the J and G. Now, if J and GE, that we do not check ZF, we do not check ZF, we only jump if SF is not equals to OF. So if they both are not equal, if it is 1, if it is 0, or if it is 0, if it is 1, then obviously it jump if not greater than or equal condition true gets true, and we shift to the address provided by the instruction. And JL, that means jump if not less. If not less, that means they both are same. Sign flag and zero overflow flag are same, and in that case it will move to the address provided by the instruction. On the next page, we have another conditional transfer instructions. The first one is JNLE, jump if not less or equal, jump if not overflow, jump if not parity, jump if not sign, jump if not zero, jump if overflow, jump if parity, jump if parity even, jump if parity odd, jump if sign, jump if zero. So we have already discussed or understood these commands JZ and JS, JPO and JPE. We have already studied. Jump if parity, that means jump if even parity. So obviously this is same. And we have already JNS and JNZ because they are similar to the sign flag and zero flag. And jump if not parity, it is same as jump of odd parity. So this they are same because we check only the parity flag. So the only thing we need to discuss is JNLE, JNLO, JO. These few instructions we need to check. So JNLE is jump if not less or equal. Jump if not less or equal, that means not less, that means it is equals to 0 for equal. And if not less, that means sign flag equals to overflow flag. These flags, sign flag and overflow flag, check basically the condition whether it is less or equal. So SF, there is sign flag, if and Z flag, they both are same, and if ZF equals to 0, if both conditions are true, then only this condition will be true and the instruction will be fetched by the address provided by this instruction. J and O, that means jump if not overflow. If not overflow, that means overflow flag has to be reset. And if it is reset, it will the condition will be true only if OF equals to 0. So when OF equals to 0, this condition will true, and this J and O address will execute the next instruction from the address provided. And we are left with only this OF equals to 1. When overflow flag equals to 1, then it will move or it will fetch the next instruction from the address provided. Clear? Next is the loop instructions. If we are studying the instructions of 8085, then obviously to create a loop, we need to have a register in which we load the count, and then we'll decrement or increment one by one based on the program we want to design, and then we check whether it is 0 or equal to a particular value by using jump commands. But here in 8086 we have a separate loop command. That means by default this CX is assumed to be a counter, and we load the value of the count in the loop, and we decrement the count for every single instruction if we want, and then we can check whether the condition is true or not. If it is true, it will go to the address, or if it is not true, then it will go and fetch the next instructions. So this loop unconditionally, that means we have loop to address, that means decrement the value of CX, that is counter, and go to address if the CX is not equals to 0. If CX, that means the content in the counter, is not equal to 0, then it will go to the address. Otherwise, if it is 0, it will fetch the next instruction. Similarly, this is the we can say it's an unconditional loop because we are not checking any condition, and we are moving by only the value of the CX. But if we have the condition like loop E, LOOPE to address, that means loop while equal. And this equal checks the content present in the CX, that means count plus the flag status. So if equal, that means if if 0 flag equals to 1 and CX is not equal to 0, it will go to the address. It will fetch the next instruction from the address and it decrement the count. So first it decrement the count, then check whether CX equals to 0. If it is, then it does not get the condition true and it fetches the instruction from the next line. But if it is not equal to 0 and ZF equals to 1, they both conditions are true, then it will fetch the instruction from the ADDR address provided. Similarly, loop Z, it is same as loop E because we are only checking the 0 flag. So ZF equals to 1, it is same as loop E command. So it checks only the Z flag. Similarly, loop NE, that means loop not equal. Loop not equal, that means we are going to check the value of the 0 flag. So 0 flag equals to 0, that means if it is not equal, and the CX is not equal to 0, the both conditions are true, then only we'll move to the address. So first decrement the counter available in CX, then we check whether it is 0. If it is, then we check the 0 flag. If this is also 0, then we'll fetch the next instruction from the address provided in the instruction. And loop NZ, that means loop non-zero, it is similar to not equal, and then that means if ZF 0 flag equals to 0, then, and obviously the CX for every single condition, the CX has not to be not equal to 0. If both conditions are true, then we'll fetch the instruction from the loop at the address provided by the loop command, loop instruction. Thank you.